Standard AI models are effectively very fast typewriters. They predict the answer one word at a time, strictly left to right, like a locked black box. DiffusionGemma uses a completely different architectural approach. Instead of writing sequentially, this model generates a massive block of text all at once. Every response begins as a 256-token canvas. It starts as a polyglot soup of maximum entropy noise, random, flickering characters drawn from dozens of different languages. The text anneals out of this noise. Rather than drafting the response word by word, the model refines the entire canvas simultaneously until a coherent answer appears. By building the entire canvas at once, we can slow the process down frame by frame. This creates a microscope that lets us literally watch an AI make up its mind. On July 13th at 3:39 a.m., an operator used a custom visual dashboard to watch this internal process step by step. They fed the model a highly constrained test prompt: write about the ocean using only D words. The operator adjusted a single variable to test the system, a dial called entropy bound. They swept the dial 10 times from 0.01 to 0.10, tracking how the generation changed across 10 different runs. The operator hypothesized that turning the dial up would act like a volume knob for chaos, creating a smooth progression of increasingly garbled text. But the resulting data shattered that assumption. A routine test instead revealed a hidden mechanism in artificial thought. The entropy-bound dial is not a chaos control. It represents the cooling rate for the text. At every step, the model calculates an uncertainty score for every position simultaneously. Certain words freeze into permanent text. Highly uncertain words melt back into noise. Unexpectedly, at step 2, half of these frozen words instantly revert to noise. This massive remelt proves the model is natively self-correcting. It actively tears down its own early drafts before the sentence is finished. While the mathematical grid was changing, the text was remarkably consistent. Every single sweep began with the exact same sentence. It always wrote, "Deep, dark depths. Distant waves dance." The word waves is not a D word. The AI failed the strict constraint of the prompt. Tracing this mistake back through the frame-by-frame data reveals it materialized at frame 3 and stubbornly refused to ever melt back into noise. Because the phrase distant waves is a statistically powerful linguistic pairing, the model's internal uncertainty score plummeted to 0. The model's hyperconfidence created a structural trap. It froze the mistake so rapidly that the AI became effectively blind to the original instruction. We see the most significant anomaly in the 0.06 and 0.07 dial sweeps, where the freezing rate behaved strangely. In these specific runs, the dashboard reported 100% commitment, meaning the model mathematically believed the generation was finished. Despite being finished, for 4 extra frames, a single word slot kept swapping between dimension and diversity. This behavior occupies the space between chaotic noise and static text. It is not the high entropy noise of steam, nor the locked solid of frozen text. It is the liquid phase, a fragile intermediate state where the AI's thought is coherent while staying perfectly mobile. If engineers can intentionally hold a model in this liquid basin, they can watch it weigh contextually accurate options simultaneously. This discovery provides a viewpoint into the moment of generation. By adjusting the cooling rate, we steer the internal mechanics of the model before the output crystallizes into reality.